Hello all, hope you're doing well. So in continuation with the previous video, we discussed about the language of chemistry, the chemical formulas. So we discussed about the charges, the naming part of different ions, metal ions and non-metal ions, and we discussed about the single element ions only. So now we are going to discuss about chemical formula rules. So this is again given by IUPAC. So I'm not writing the full form, it's International Union of Pure and Applied Chemistry. So now when it comes to writing chemical formulas, if we know the charge or the valency of the metal and the non-metal, then it's quite easier for us to predict the chemical formula. Now this whole activity requires a lot of practice. So it's not easy in the beginning, but with thorough practice, it will be quite easier for you the later on. So it's very difficult in the beginning for sure, but usually it will take some time to memorize. And as people say, everything is difficult in the beginning. So when we talk about chemical formula rules, I start with this one. So in a chemical formula, generally metals or an element carrying positive charge is written on the left hand side of the chemical formula, and non-metals or element carrying negative charge is written on the right hand side of the chemical formula. The valencies or charges get crisscrossed during chemical formula formulation. Total charge on the chemical formula is zero. So it's electrically neutral. I'm talking about the chemical formula. So we can write one example. Let's say we want to write the chemical formula of magnesium chloride. See, IUPAC designs chemical formula in the way that it will try for inorganic compounds most of the time, that it will try keeping magnesium. It will not try, it will keep like not magnesium, metals on the left hand side. So that's what I have written. The metals or any element carrying positive charge on the left hand side, and non-metals or any element carrying negative charge on the right hand side of chemical formula. So from the name itself, it's understood that we need to keep magnesium on the left and chloride on the right. So first step is writing the symbols. We have magnesium, then chloride is Cl, it's chlorine. So since they are forming a compound, magnesium chloride, it's an ionic compound. So the name of chlorine will be changed into IDE. So that indicates that it's a part of a compound. Now we know that we write chlorine as Cl minus and we write Mg2 plus like this. So we're going to take this number 2 and we are going to take this minus 1. Just I'm writing it as 1 over here. You can write the charges, that's not a problem. But I have a different way of explaining it. So this number will go at the bottom of this magnesium metal. This will go over here. So the formula will become MgCl2. Now, how do we understand this? Like how this happened at the first place? See, magnesium carry plus 2 charge means magnesium can donate 2 electrons. One atom of magnesium can donate 2 electrons, but one chlorine atom can accept only 1 electron. So, how many chlorine atoms need to chemically bond with magnesium? One magnesium atom. So, the answer is 2. So, we are going to add the total charges over here. Chloride is carrying minus 1 charge, and this subscript, this is what we call the subscript. So, in a chemical formula, subscript indicates the number of atoms to whichever element it is attached. So magnesium, there is no number, so it indicates only one atom of magnesium is there. Chlorine, two atoms are there, so minus 1 is the charge on one chlorine atom into the number of atoms. This will give you total charge as 0. So this is another identity of a chemical formula, that the total charge on the chemical formula should be 0. If it is not 0, that means you have done some mistake, or the valencies are not correct, or you messed up over here. Anything is possible. Now another example we'll take. Aluminium oxide. So aluminium oxide, first thing comes to our brain is aluminium symbol Al. Oxide, definitely it has to be O. Now, if you go back to the chart which I shared in the previous video, so aluminium carry 3 plus charge. This is how I wrote aluminium, and oxide is O2 minus. So again, we are going to take these numbers 3 and we are going to take this 2. So this will go at the bottom of aluminium, 3 at the bottom of oxygen. Formula will become Al2O3. If you want to check the total charge over here, so aluminium carry plus 3 into the number of atom. This 2 indicates number of aluminium atoms are 2, plus oxygen, oxide is minus 2 on each oxygen into the number of atom. So this will be plus 6 and this will be minus 6. So if you add it up, this will be 0. So it's electrically neutral. Again, we are keeping aluminium on the left hand side and oxygen, non-metal, on the right hand side. So we'll take one more example. Calcium oxide. So I took this example with the purpose for explaining you one important point. So calcium is Ca, we know the symbol. Oxide is again O. So we write oxide is O2 minus. Calcium is also divalent. Both are divalent. So in that case, we follow a concept of highest common factor. This 2 and 2 will cancel with each other and we are not going to write Ca2O2. Please remember, this is wrong. So we will write CaO because it's the same number. So the same number, following the concept of highest common factor, it will be cancelled off and we will get the formula as calcium oxide, CaO. So logic behind this is one atom of calcium can donate how many electrons? 2. One atom of oxygen can donate how many, can accept how many electrons? Two. So definitely only one atom each from both parties is required. We don't require, you can say, multiple atoms because of the valency. So chemical formula writing is mainly about the valency, mainly about the combining capacity of the metal and the non-metal, what correct formula we will have. Now, why this chemical formula is so much essential in chemistry? We have a very famous mole concept in chemistry that's a part of physical chemistry. I always say without mole concept, we can't survive in most of the chapters in 11th and 12th grade. So it's very much essential for us to understand it to depth, like in depth. So if we are writing the chemical formula wrong in the mole concept, like if it's asked some numerical and if we calculate the mass of the chemical formula wrong because we predicted the chemical formula wrong at the first place, definitely the molecular mass is going to be wrong over there. Ultimately the whole numerical will be wrong. So it's very much essential to pinpoint these chemical formulas. It should be on the top priority when it comes to chemistry because it's going to govern your future classes. And without the basic fundamentals, without these basic, you can say, this naming part, the language of chemistry, it's very difficult to survive. Because if you know element, symbol, you can write a chemical formula. If you know chemical formula, you can write equations. So just like you have A, B, C, D alphabets, so alphabets combine to form a word, word combine to form sentences. Similarly, in chemistry, symbols combine to form chemical formulas, then chemical formulas into equations. So equation writing will be very tough, and those equation writings are very much essential for your mole concept. So everything is linked. One thing left unturned in chemistry can be very much expensive in the future. So we'll take one more example, and after that, I'll be giving you one chart that you can just practice on your own later on. That's like we can make it over here. I'll not be completing that chart, that's a homework for you. So we'll be writing one more example. So I'm taking this barium peroxide. Now, if you see in the previous chart, barium symbol is Ba, barium valency is 2 plus. Peroxide we write like this, O2 with the 2 minus charge. So can you see this number 2 over here? So we will write 2 over here. I'm not showing this 2 minus above over here because this need to be crisscrossed. But again, we need to see one more thing, that these two numbers are same, so they will cancel off. So you just have to club this entire formula, that is BaO2, without doing anything else. So if we want to compare, the charge, total charge is 0 over here, barium plus 2, then peroxide is minus 2, it will be 0. So barium oxide formula will be different. Barium oxide will be BaO. That's it. Because barium is divalent, oxide is divalent. Over here, you can say the tricky part comes with the formula of peroxide. We forget the bottom number over here. Peroxide is not a single element ion, no doubt. It is made up of same atoms, you can say, but it is having two atoms and there's a collective charge. So they'll be different. So I'm writing for your reference so that you can remember. Barium oxide formula is BaO. Barium peroxide is BaO2. Now you can try with this. What is barium superoxide? You try. I'll not do it. So the chart part which I was talking about, that we're going to write now. So what I want you to do, you can write some ions over here. You can write sodium, Na plus. Like you write the formulas on your own. You have the chart. I discussed about that. You can just follow up from there. Find your rat. Like in the beginning you have to do this. Don't take it as a test. It's a practice. So what you need to do over here, you have to take reference from the chart which I have given, or any other reference that you have, any book, any online data, anything. But the idea is to remember. So we will write sodium, then we will write, we can take another example. Let's take zinc. Then we can take aluminium. We can take magnesium. So I'm taking only four. This is one example I'm showing over here. You can make it on your own. So over here we are going to write nitride. We are going to write oxide. We are going to write phosphide, and we are going to write chloride. This is a very small chart which I am giving right now. So I'll give you one example. You can make it on your own also if you want to. So we know sodium is Na plus and nitride is N3 minus. So at some point of time you have to be so pro in this that you need to do the crisscross method in your brain. So the formula over here is going to be Na3N. So nitride is 3 minus, that will go at the bottom of sodium. Plus 1, nothing will happen to nitrogen. This is one atom only. That's a formula of sodium nitride. Then zinc nitride. Zinc is Zn2 plus, nitride we already know. So this will be Zn3N2. So it's a crisscross. 2 will go at the bottom of nitrogen, 3 will go at the bottom of zinc. So this is zinc nitride. Formula done. And you have to write the names also along with it in order to understand it better. So if you have a long chart of this, I think online you can get a lot of multiple charts like these where you can actually do the crisscross part, and you can actually make a lot of you can say compounds like this, and you can even remember, because by the time you're going to reach over here you're going to practice this multiple times. So this sodium oxide is O2 minus, so this is your Na2O. ZnO, because 2 and 2 same number. So same with aluminium you can do. Aluminium is 3 plus. So this will be, so 3 and 3, nitride is 3 and aluminium is 3. So this will become Aln. Then if we talk about this magnesium is 2 plus. So Mg3, N2. Yes. So that's the formula of magnesium nitride. Write the names also along with it. So this you practice on your own. I'm not completing it. If you want, I can complete it, but that will be spoon feeding. So I don't want to spoon fed you. I want you to learn something on your own. So I'm leaving this over here for you to practice and complete. You can get these kind of charts on multiple platforms and you can practice. You can take a printout of those. You can practice. Then moving ahead to the next part. So the next part is polyatomic ions. We even call them as radicals or molecular ions. So how do we define them? So these are group of atoms having a collective charge on them. So poly in chemistry stands for many. That means many atoms are going to be required. We know atoms are only of two types. Oh, sorry, we know ions are of only two types, not atoms. So we have cations, we have anions. Now, in the single element ions, there were many number of cations, but in your polyatomic ions, anions are more in number. We don't have much cation. We just have one NH4 plus, and the name of this is called as ammonium. So NH4 plus, when we say, see, remember how I'm calling it out NH4, and then in the last I'm calling it as a plus charge, because this plus charge is a collective on nitrogen and hydrogen, and nitrogen hydrogen are covalently bonded together. Even in spite of that bonding, they are having a plus charge. So again, these ions are not floating freely somewhere. They are a part of compound, they are a part of molecule, they are combined in some formula, they are not alone. So similarly, we have too many number of anions over here. So wherever possible, I'll help you out with a learning trick, but it's a difficult job, but still you have to learn these anions in order to become very pro in your chemical formulas part. So I start with anion. Let's start with this carbonate, CO3 2 minus. So it's a collective charge. Then we have hydroxide. We have cyanide, Cn minus. We have oxalate, C2O4 2 minus. Oxalate comes from oxalic acid formula. If for your reference, if you know oxalic acid, this is the formula, or we can write like this: H2C2O4. In your lower classes, you might have heard about oxalic acid. I think it's present in tomatoes. So it's a weak acid. It's an organic acid. So if you remember, if you just remove this hydrogen, you will get C2O4 with the 2 minus charge. That is oxalate ion. It's a part of oxalic acid. Then we have chromate, CrO4 2 minus. Then we have dichromate, Cr2O7 2 minus. So how to remember this? If you can see a pattern over here, both chromate and dichromate are having 2 minus charge. If you can see it, this collective charge is same. Now chromate has only one chromium atom, four oxygen atom. When we are increasing the number of chromium atoms, definitely the number of oxygen atom is also increasing. Now this whole, all numbers are dependent upon the bonding part that you'll be studying later on, not right now. Then we go to acetate, CH3COO minus. Acetate comes from this acetic acid. It's an organic acid. Acetic acid is also present in vinegar. Then we can write about zincate, ZnO2 with a 2 minus charge. Aluminate, AlO2 with a minus charge. Meta-aluminate is AlO2 with a 2 minus charge. So aluminate has only minus 1 charge. If you can see, meta-aluminate has 2 minus. Rest of the formula is exactly same. So you can remember it. Now, if we there can be many radicals. These are only few that I'm writing over here, but the most common ones are very confusing sometimes when we hear when we hear the name. So I'm writing over here few examples. Then we are going to go with the learning trick. Now you might have seen SO4 2 minus, SO3 2 minus. So, how to remember it? So, this is again a learning trick. So, the suffix will have 2, 8, and the suffix ite. So ATE stands for more number of oxygen atoms bonded to non-metal. Whereas if we talk about ITE, less number of oxygen atoms bonded to non-metal. So if we keep this thing in mind, so we have to compare this, more oxygen, less oxygen in comparison to the radicals. If you see this SO4 2 minus and SO3 2 minus, they both have same elements, sulfur and oxygen. Oxygen is having more number of oxygen atoms, so we will write the suffix ate over here, sulfate, less number of oxygen relative to sulfate. Okay, this is relative. This is again bit dependent upon the bonding. Sulfate is a radical which is used in sulfuric acid, H2SO4. Sulfite is a radical which is used in sulfurous acid, H2SO3. So these are part of compounds, part of molecules, acids. It can be any salt also. It's not only acids. It can be used anywhere. So this is sulfide. Now you have to keep this thing in your mind. What is sulfide? I'm writing it for your reference. IDE has a different meaning. IDE in sulfur meaning no oxygen atom is there. The best part over here is all three are having 2 minus charge. They all three are divalent over here. So if you can remember this trick, it will be very easy to remember all three radicals without any confusion. So ATE, more number of oxygen atom. The only thing that you have to remember is the formula of this. A picture of these three radicals in your three. You can say these ions, three ions in your brain. SO4 2 minus, SO3 2 minus, S2 minus. Which one is what? We can figure it out. The one having more number of oxygen atom relative to each other, that is going to be sulfate. Less number of oxygen atom, that is going to be sulfite. No oxygen atom, that is going to be IDE, sulfite. Now similar to this, we'll take one more example. NO3 minus, NO2 minus. Then we'll take PO4 3 minus, PO3 3 minus. So if you see, the valency or the charge is going to be different because every atom has different number of electrons. Every atom has a different kind of valency. So it all depends upon the bonding, why there is a change of numbers in all these radicals. It's because of the different elements chemistry. So which one is going to be phosphate, which one is going to be phosphite, you can figure it out. The one having more number of oxygen atom, so we will say it phosphate. Less number of oxygen atom, phosphite. Similarly, nitrite will be NO2 minus, nitrate will be NO3 minus. Now I'm writing over here for your reference what was N3 minus. This was nitrite. So now by, you can say, coincidence, we have sulfur, sulfide, ITE, ATE, all divalent. But that's not the case of nitrogen, N3 minus, totally different. So it depends upon the chemistry, electronic configuration over there. But we can remember this. IDE means no oxygen atom and the valency or charge over nitrogen is 3 minus and it's a non-metal. Now if we talk about P3 minus, now this is easier to remember because all three are trivalent. PO4 3 minus, PO3 3 minus, P3 minus. So this is phosphite. See, I'm writing these single element ions for your reference so that you can picture it in your brain that how to remember all this. Otherwise, it becomes very confusing during the examination. Okay, what is phosphate? What is phosphite? What is phosphide? Well, if you have this trick in your brain, you can figure it out. And these are not difficult to remember. It will take some time. Put these charts somewhere on, in front of you, wherever you sit. So look at it for 5 minutes daily. It's not a difficult task. Now, one more example that we're going to take over here for these is so if we talk about these anions, I call them chloro-oxo anions. Actually, they are a part of oxyacids. Oxyacids we can discuss in future video somewhere. So chloro-oxo anions, there is oxygen, there is chlorine, and it's an anion. Now the best part over here, it's in the sequence ClO, one oxygen atom, ClO2, second, two oxygen, three oxygen over here, four oxygen. So all are monovalent, easy to remember. Now the tricky part comes in the naming part. So again there is a trick. So if you can remember ClO2 minus as with the name chlorite, just remember one oxygen atom less than chlorite will have a prefix hypochlorite. Like the name will be same. Chlorite is not changing. Just that added prefix is coming when you reduce one oxygen atom. One oxygen atom more than chlorite will have a suffix chlorate. Sorry. So chlorate over here is ATE suffix, means more number of oxygen atom compared to ClO2 minus, that is ITE. Now one oxygen atom more than chlorate will have a prefix, this is perchlorate over here. So chlorate name is going to be remaining same. So if we say, let's take an example of any compound, sodium perchlorate. So sodium perchlorate is sodium valency, we know that is 1. We write sodium like this. Perchlorate is ClO4 with the, I have written above ClO4 minus. So 1 again. So if you crisscross in this, you don't have to do anything. You just have to club the ions, atoms, you can say over here. NaClO4 is the formula. That is sodium perchlorate. So if you can remember this trick, it will be easier. So remember from this part, chlorite, ClO2 minus is chlorite, one oxygen atom less than chlorite will be having a prefix hypo. Hypo means less. One oxygen atom more than chlorite will have a change, slight change in the suffix part. It will be ATE. One oxygen atom more than chlorate will have a prefix added up over there, perchlorate, but the chlorate part name will be same. So I hope you have understood this part. Then now coming to another type of radical ions. So I again club it with something else. Now you might know about this. This is bicarbonate. Now we can even call it as hydrogen carbonate, not a problem. So but usually this is old convention of writing this radical bicarbonate. We can say sodium bicarbonate, that is a very common compound used in chemistry in most of the chemical reactions, NaHCO3. That's a formula. Now how to remember it? So how I have memorized all these ions, I'm just sharing the trick with you. So if we say carbonate, CO3 2 minus. So when you're going to add one hydrogen, the 2 minus charge is getting reduced to just 1. It's decreasing in the number, right? So the rest of the formula is going to remain same. CO3 is remaining same. We are just adding hydrogen and 2 minus is changing to 1 minus. It's getting reduced. Now, if I say HSO4 minus, this is what we call as bisulfate. So we can remember from sulfate. Sulfate, if we can remember, that is SO4 2 minus. Bisulfate will be HSO4. SO4 is not changing at all. The formula doesn't change. The charge is going to be decreased by one number, and You can say you can say, I won't say the charge, like the number is getting reduced, right? 2 minus to 1 minus, like that. So the name remains same. Carbonate is still carbonate. By sulfate is still sulfate. Then we can take phosphate, PO4 3 minus. Biphosphate will be HPO4 2 minus. We can take phosphite, PO3 3 minus. See, biphosphate has phosphate. Name is not getting changed over here. So it's phosphite. So we will write HPO3 with the 2 minus charge. This is biphosphite. Then we can write sulfide, S2 minus. We know about that. Bisulfite, HS minus. You can write sulfite also, SO3 2 minus. HSO3 minus, bisulfite. So we can remember these bis like this from their original radical by adding hydrogen, reducing the number over here. So it's quite easy to remember. Now coming to some examples of chemical formula. So if I write ammonium dichromate. So ammonium is NH4. We know we write ammonium like this, NH4 plus. This plus indicates just one valency. Dichromate is Cr2O7, and we write dichromate with the charge like this. So this 2 minus, I'm writing just 2 over here. This will go over here. So we will get NH4 whole twice. Cr2O7. Please do not write like N2H8. Okay, don't multiply it because this NH4 is just one entity. It's an ion. So dichromate valency is 2. So 2 ammonium ions are chemically bonded with one dichromate radical. So do it like this, whole twice. So this is the chemical formula of ammonium dichromate. Then another example we can take is magnesium phosphate. Magnesium is 2 valency. Phosphate is PO4. PO4 with the 3 minus charge. So this will be Mg3 PO4 whole twice. Now if I say magnesium phosphite, the only number which will be changed over here is 3 PO3. Mg3 PO3 whole twice. So I'll write it over here. Mg is 2, phosphite is PO3. So Mg3 PO4 twice. So total charge is still same. It's plus 2 into the number of atom 3 plus phosphate is minus 3. One phosphate radical is minus 3 into the number of atom. This will be 0. Plus 6 minus 6 will be 0. Same over here also. So there can be multiple examples for this, for these compounds. Again, you need to remember this chart so that you can write chemical formulas. And the more chemical formulas that you practice, more it will be easier for you to remember these radicals with full confidence. So I hope you understood all these concepts. We'll meet in the next video. Thank you for learning with me.